Hey guys, I'm excited to bring you this new series assembling your city. So we're going to be talking about in this tutorial about some modules, so certain smaller parts of the buildings, and then in the upcoming tutorials we'll go over how to generate the shape of your building and how to think about this project and the hierarchy. So without further ado, let's dive into Photoshop. We're going to be talking about city generation, but city generation is kind of vague if you don't know where to start from. So we're going to start with buildings. And what is a building? So let me draw a really simple building, which is basically going to be a cube or something. It's really lovely, I know. And another cube at the back or something like this. This is going to be our building. And then what buildings usually have, they have windows and they have a lot of horizontal stripes, they have different floors. But what you usually can see is that buildings have very distinct rectangles which you can use as modules. So if I would give that another color, this will be one of those modules, this one. And then this would be a different module. And same goes for this one. And then you have all these modules, which could be different things. They could be a door, they could be a wall, they could be a special window, or they could be anything what you want them to be. Or they can even be pillar. If they are horizontal in the middle, or they are vertical and they are in the middle of your building, then they might be a pillar. They could be a lot of stuff. But when I was busy with this, I'm going to delete this part real quick. And let's just grab one of those buildings, which is basically a rectangle. So we have this rectangle over here. And when I noticed, when I was using this rectangle, like the things you want to know is what is the top part, what's the bottom part, which parts are connected to a wall, and so on. And when I was saving all that information in these rectangles, it became really annoying because, well, first of all, we have the first 4 information points we have are the points themselves. Those contain their position. Those are the first points that have information. Well, then we need to know what is the bottom part. Well, that could be this one. But then we also need a hierarchy, to know which one are on the sides, and so on. And this became very tedious very fast because there were just so many attributes going on and went everywhere, and it didn't feel like having so much control over the hierarchy. Then I changed this one to, I'm saving, that's also what I will be doing in this tutorial. I will be saving all our information in only a line. And this line will have then 2 points, and those 2 points will be having the directions of the wall. Now that will be a direction going upwards, so let me delete the original one again. There we go. So these lines would be basically describing the exact same wall piece, but now I already know the hierarchy because the first one is the floor. Then the 2 directions are basically the walls, and then the top part is going to be the ceiling. Thus, with almost no attributes, only the position and then directions, I already have the hierarchy. I already know so much stuff, and it's very flexible because if I would be changing this bottom primitive, everything changes with it. And then I could just inherit these attributes later on to get the right direction. It's very flexible, which also makes it very easy to store in this primitive if it's a certain type of wall, and then in the primitive next to it, it can just easily check, oh, what's next to me? Oh, you're this kind of window, which means I need to be something else. And that's what we're going to be focusing on, these kind of modules for our buildings. And then in a later tutorial, we'll be making a giant city. All right, so let's dive into Houdini. All right, let's start as always with placing a geometry node. Dive in and place a curve. We're going to start by making a rough shape of our building because we're first going to do the module. We're not really caring that much about the shape of our building yet. So let me just draw something funky. Alright, I think that's alright. Let's close it and now enter perspective mode again. So we're going to start with this. Let's place a resample, and this resample is going to create the basis for our modules right now. So resample by polygon edge, and let's set it to something like this or a little bit smaller. Yeah, that should be fine. All right. Now after this, I want you to place down a convert line. So the convert line, not the convert node, the convert line will transform each segment in its own primitive, and that's what we want. So there we go, the convert line, and here we go. So now we have a primitive for each segment. Then place down a facet, because I want each segment to have its own separate 2 points. And this facet is going to create unique points. And now we have unique points for all of our segments. After that, place down a polyframe. And this polyframe is going to help us to determine what the inside of the building is, basically. And that's by getting the tangent. So this tangent right now, it points in one direction, but if you look carefully, you can see that over here it's reversed. And where is it reversed exactly? Well, we can look at our convert line, and that is at our number 0 primitive. And that is because, if I would explain this really fast, if you look at the points, the convert line takes point 0 to 1 and it sees, okay, the direction goes from 0 to 1, so that's going to be the direction. Same for 1 to 2, same from 2 to 3, the direction will stay the same. But here, the direction is inversed because it sees, oh, 0 to 29. That means the direction goes from 0 to 29. But that's not what we want. And in our convert line, it is primitive number 0. So we can place down a reverse node that's going to reverse the primitive number 0. And this will solve our little problem over here. So if we would now look at our normals, they are still flowing in the same direction. Nice. All right. After this, you can place down a null node, and this null node is going to be our control node. It's going to have 2 variables, and there are tons of ways to do this. For now, this is an easy one to do it. I'm going to have 2 variables, one called total height, and the other one is going to be called floor height. All right. These 2 values are going to be what we need. The total height is going to be, let's say, 40 meters high, and the floor height, let's set it to something like 2 for now. They're not really to scale, but doesn't matter that much. And let's call this now the control node. Then we're going to place down a copy node. And this copy node is going to be a copy and transform. And with this transform, well, it needs to be at the total height that we are going to pick. So we're going to take our total height, we're going to throw it in here, and then we're taking our floor height and we will divide our total height with the floor height. This means we have the correct amount of copies. Now, this number we're going to take, we're going to put it in the y direction for the translate, and we're going to take the total amount of height, or the floor height, that's even better. Well, you could do 2 things. So right now we have the total amount of copies, and it's easier to take the total height and then again take the total height and divide it by this number. Okay, here we go. So right now I'm only using whole integers and everything divides into whole integers. But the cool thing about this is that if you right now would extend this value, the total height, everything goes smoothly. So you have a lot of control about the exact height. Maybe you want to have more control about the exact floor height, then you should set this up a little bit different. But for now, we don't care that much about it. Then we're going to add an attribute, and I'm going to do this with a point wrangle. And this point wrangle is going to contain this height value. And this height value is equal to this, so let's copy parameter. And let's name it height. So float at height is going to be equal to a channel called height. And then let's press this button, and we have this channel over here right now. Let's paste it in there. And now if we go to our geometry spreadsheet, you can see we have a height value. So right now it's the same for every point, but later on we're probably gonna have different heights, different values, and each module is going to be able to solve this on its own. Really nice. For now, this is good. Let's place down a for loop. We want to make this for loop over each module separately, and to do that, right now we can do it with primitives. So let's fetch piece or point. Then we're going to set this also to piece or point. This needs to be the same as the this needs to be the same as the piece block path. We want to loop over primitives. We don't need the piece attribute. And did I forget something somewhere? I don't think so. We're not merging everything at the moment yet. So let's set this to merge each iteration. And now you can see it's very small, but we're looping through the entire building and each module separately, which is what we want. So nice. Now, next up, I will place down a subnet and I will dive in. Here I'm going to set the up attribute. So I'll place down a pointer angle. And this pointer angle, I'll set the up attribute real fast, is up.y equals 1. And now if we want to visualize this, so here is our primitive. We can go, we can press D and we have display options. We can go to visualize, scene visualizers, a marker. Let's change all these names to up. It's going to be a vector. And I want it to be green because that's 0, 1, 0. That's the exact same value. Nice. All right, there we go. Here is our up vector. After this, so this is our module. Now we want this module to, well, design it. For example, we want it to be a window. Now the window is in the middle. Then we have two parts of walls. And how do we do this? How can we divide this? Now for the horizontal division, we can use a carve node. And let's do it like this. Let's place down a carve node. And let's activate the second view also. And let's set this to 0.15. Just a nice value. Whatever you like. And the other one's going to be 1 minus the first one. Which means it's now a little bit smaller than the original. There we go. If we copy this. And we only select the first one and we keep outside, then we get the first piece. And we can do the same thing for the second part. And let's do this. There we go. Now we have two different segments. Really nice. Then I'm going to place another subnet. And inside of this subnetwork, I'm going to create a plane out of well, this thing. So with a pointer angle, I can access the height. So we have the height and we need to offset this primitive by the amount of the height in the direction of the up vector. And we can do this by typing the original position, and we're gonna add to that the up vector multiplied with the height. F at height. There we go. And if we do this right now, it is transformed up, or in towards the up direction. And if we now place an add node and a merge, we can create a cool plane out of this. Nice little primitive. Ooh. This one in there, this one in there, and then drive it into the add. Make sure we delete geometry, go into the polygon, and 0, 1, that's for the first primitive, and the other one needs to be reversed. So then we're going to press 2, 3, and then 2. Because we always know this is going to be 4 for now, fine. And let's close this. We've got our little asset that can create planes based on the height. Nice, that's what we wanted. So let's set this one over there, and also let's set this one over here. And place down a merge. And there we go. That's it's a little bit tall. Let's go inside of our control node and let's set the floor height a little bit lower. There we go. It looks a bit better. Now, this middle part is going to be our window, but we also want to have the same kind of offset, but then in the height. And the way we can do that, it's also quite easy. So let's grab this carve node And with this carve node, well, we can place down a point wrangle. We need to do two things this time. We're going to need to adjust the height, and we need to adjust its own Y position. To do this for the first segment, that's quite easy. The only thing we need to adjust really is the height. So we're going to place down a height. We're going to multiply this with a channel, and this channel I'm going to be calling F. There we go. Let's close this. Push this button again, and there we go. And now we can place the same subnet after this again. And if we now change this value, we can manually adjust this in a 0 to 1 scale, which is a 0 to 1 scale of our original plane, as you can see. So that's working nicely. We don't want this to be a 1, we want it to be somewhere at the bottom. So now we have the bottom segment done. Now we're going to do the top segment. So let's copy over this point wrangle. And now we're going to type something a little bit different. So the height is going to be the same, because we only need one variable to adjust the height. But first we're going to be adjusting our b.y direction. You could do the same trick again with the multiplying the height with the up vector, but for now I'm just going to do this because it's kind of easy. Plus equals f at height, and then that one is going to be multiplied with 1 minus our f channel, and this means it will be sticking to the top. It's always nice, what I would recommend is to think about this kind of little mathematical trick so you really understand it. It helps a lot to do these kind of tricks and really make a modular procedural system, which is what we want to end up with. Alright, there we go. Then we can place this subnet again. And now we have basically the same, but then for the top part. Now the middle one is going to be well, it's not really that complicated, but it's going to be the most complicated. So let's look here, and first we're going to offset the y again, the y value. And to do this time it's really easy because we only need it to be the same as the first one. So we don't need this 1 minus thing anymore. And we only need to multiply it with the f channel. And to do this, we can just go over here, copy this value, and copy it over here. Of course, you could do all of this in one giant wrangle, but for now I keep everything separate, so it's easy to see what's going on. So let's copy it in over here. There we go. And now it's at the correct height, but it also needs to have the correct length. And for that one, we're going to do something slightly different. But over here it's quite easy. So we're going to change this height, but we're not going to change it to multiply with channel F. We're going to make another channel. This channel is going to be called G. And let's run this. And this value is going to be 1 minus our first value and minus our second value. There we go. Then place a subnet. And now, as you can see, we have all three values, and the middle one could be our window. So let's merge these three together. Here we go. And now, if I, for example, would place a poly extrude, I'm going to disable this later because poly extrude is kind of, yeah, it can crash really hard, and I don't want that to happen. But so if we don't change the distance, but we're going to change the inset, and then don't take the output front, you can see we have the basis for a cool window. Now that's all cool. I'm gonna remove this one for now, and I'm just gonna give it a different color so you can see it's a window. There we go. And now the next trick. The next trick is how to work with angles, because we know now how to offset something in a certain direction, but what if you need something at a certain angle that's relative to your base angles, your base directions. So for that we are going to, for example, we're going to need a roof, and this roof is going to come from over the top. And then I first need the top part, and I can get that using this little point wrangle. So right now, oh, went wrong. Oh yeah, of course, needs to go over there. There we go. We have our top height. So this is where we're gonna create a roof from. After that, I'm gonna use a point of just to mix it up a little bit. Of course, you can also do this inside of Vex, whatever you like, whatever you prefer. And then in here, I will first transform. I need a quaternion. First thing I need is a quaternion, and I need to get our up vector because I want to rotate our up vector around the normal. The normal is going to be the axis. This is going to be up, and it needs to be a vector. Then I know that the axis is going to be the normal, and the angle I will just promote this one, and this quaternion I will be converting it to a matrix. So quaternion to matrix 3, because we don't need any other transformations or something. We're just going to rotate. Now we have this nice matrix. What can we do with this? We can multiply this matrix with our up vector. It's as easy as that. Let's multiply it. Wire in the matrix. And there we go. If we would now place a blind export just to look at our up vector to see what happens to it. Well, right now the angle is 0, so nothing will have happened to it. But if we wire this in here, set it to a vector, and we go over there, and we change the angle, you can see we are changing the angle of our up vector. And the important thing to note is that it's using pi radians. So 1 pi radian is the half of a circle, so that's 180 degrees. So 2 pi is going to be approximately 6.4 or 6.3 or something, and that's going to be 1 full turnaround. I want it to be around approximately this. This is going to be how tilted our roof is going to be. Then I can do the same trick again because the up vector is now changed. I can use this little box again to now create a cool plane based on the height. But the height is still the same, and I want to change the height also. So let's change the height. Yeah, let's change the height. So let's take a bind. Let's gather the height, and let's place a bind export. Yes, I should have done it in Vex probably. And let's place it there. Then wire those into each other. Place down a multiply. Remove parameter, and now we can change the length of our roof. As easy as that. And the cool thing is we have some nice oriented, these values you see, the normal and the up, those are orientation attributes. So we can also immediately use them to, for example, place your objects. Because I don't know what you want to place. I'm going to place, that's a little bit heavy. Let's just place a box right now. And this box is going to be a small box, and I will, with a copy to points, I will place it on top of the corners of the roof. There we go. And this is how you could, for example, place the objects of your artist. You can scale them a little bit, but it makes it way easier to make a very procedural module for your building. For if your module is a little bit higher, a little bit smaller, or whatever, you can, for example, with resample node, you can adjust the amount of blocks you're placing over here. So we can do that. We can place down a resample node. If you would resample this, and let's set it to around, let's set it to a nice distance, and let's also make the box a little bit smaller. There we go. Let's make this a little bit smaller. Now we also don't need those the up vector right now anymore, so let's just move this and also remove those normals. Resample by polygon edge. So this way you can really with a lot of flexibility, place those objects your artist or yourself made. Now let's throw everything inside of the same node so we can see how it all looks together. There we go, and also this one. There we go. Now let's also give it some normals and add the final 2 parts to it, which were over there. So this is going to be our very simple, weird building module for now. So we've gone over a few different things, how to place objects, how to rotate them, and how to offset them based on their direction. And now I want to teach you how to use a random value. Right now I'm going to use a expression for this. So if we look at our final building and we set this to to run over everything, you can see we have a lot of modules, and this takes a while. But now we have our weird building. This is going to be the basis. But if you want to have some variety over here, which is something you usually want to have, we need some place to get our random value for. I would really argue against getting your random value from the position, because then when you start moving your object, everything becomes really weird and flickering, and it feels like you lose control. But if you use the iteration value, so if we create a meta input node, in here there is an attribute called iteration which holds the current iteration value, then it maintains a lot of its consistency. Now, how to get this value? First we go into this node. I'm gonna add a little parameter over here, and this one is going to be a detail path towards nothing, because it's itself. And after that we need our iteration attribute, and it only has one value, so let's pick number 0 for that. There we go. Right now you see the amount of iterations we have. Let's scale that a little bit down so it's a little bit faster, 20 or something. There we go. And now you can see we have it will cook it again, and you can see we have 629 iterations. Now, to get the current iteration, I'm gonna place a switch node right now, and I'm gonna make a variant on our building module. Later on we're gonna do this all a little bit more optimized. This is just to show you guys where to get your information from, and for that it's easy to use the expressions. I'm going to copy this subnet. Oh, it's gonna take a while. And I will look at this subnet. Right now it's a window, but for example, I don't want it to have a roof. Just gonna remove the roof, and this is the variant. So we have one with roof and we have one without. I'm gonna place this one in the switch. And in the switch I will place a if statement. And this if statement will, or not an if statement, but we're gonna take our value, and I'm gonna place it in there. Then I'm just gonna take a random value from this, and I will multiply it with 2 because it's a 0 to 1 range, and it will be rounded to basically the closest one, which means we should get an amount, kind of an even distribution, as you can see over here. So quite some normals are inverted right now, but I think you guys got the basics. So short recap, we went over how to do some transformations for your separate modules based on their directions. We went over the angles, and we got to the placing of some objects based on those directions. That was it. I hope you have enjoyed it. If you did, make sure to follow us online and maybe even drop a like. And for now, this was Dokai. Bye bye.